Hello, everybody, and welcome to the LIUniverse. I am your host, Dr. Charles Liu, and please, as though it were natural to your language processing, call me Chuck. As always, we have our co-host, Allen Liu. Hi, Alan.
Hello.
Hey, have you observed any unusual cosmic phenomena lately?
Oof, any particularly unusual ones lately? Well, I haven't seen this with myself. I have to go get some eclipse glasses and see if I can check it out. There's apparently a large sunspot on the sun right now with a line through it. It's like sort of dividing into two adjacent sunspots.
Whoa.
So people are watching to see if it's going to give a flare off or not, but it's pretty big.
Oh,
I could get more aurora. That would be awesome.
That would be nice. Yeah, amazing that we had 2 aurora visible down here in the metropolitan New York City area in just 1 year last year, 2024.
Yeah, maybe we'll get a third this year. That'd be great.
I would love that. That'd be very cool. And for somebody who would be well positioned to see such a thing up in Rochester, New York, we have Sadie Coffin with us today as our special guest. Sadie Coffin, hello.
Hello.
Hi, Sadie. Tell us a little bit about what you're doing, and we're going to talk about it in much greater detail in just a few moments.
So I'm Sadie. I am a PhD student in my 4th year now as a graduate student studying at Rochester Institute of Technology, and I am working on galaxy evolution. So I'm studying galaxies and their light. And yeah, I have nothing else to say.
Oh, not yet, but you will, young Jedi. You will. Oh, it's so great to have you, Sadie. Thank you. And as astute members of our audience will actually remember that Sadie was one of the people in our TikTok series some years ago when I went to conferences and asked people about what they do and how they do and things like that. So I'm pretty excited, and I can't wait to ask you all kinds of stuff that you do, because I already know some of the things you do, but I want to know more. All right. So beyond that, let us start right away with today's joyfully cool cosmic thing of the day. Oh, I did 2 different days in there. The today's of the day.
Days of the days.
I gotta
Not
do
the worst
better.
you've done.
Okay, thank goodness. Anyway, today's cool thing has to do with a spacecraft that we talked about in a previous episode, in a previous season, actually. It's called Lucy. Alan, you remember, right? Freya Holloway, our guest, was involved with the Lucy mission, and the Lucy mission is a spacecraft that is heading to asteroid belt stuff, and it's actually already kind of there, right?
Yeah, it's headed to the Jupiter Trojans very specifically.
Yeah. And it has just done one of its cool milestones. In April of 2025, the Lucy spacecraft flew by an asteroid called Donaldjohanson. Ah, that's so cool. Who is Donaldjohanson?
He was the dude who discovered the fossil Lucy that the spacecraft is named after.
Oh, the one after that the song Lucy in the Sky with Diamonds is named after?
No, the song Lucy in the Sky with Diamonds came first. The fossil was named after the song, and the spacecraft was named after the fossil.
Oh, fantastic. Well, it is very cool. It appears that all the instruments
I guess the fossil was in the ground before the song happened. But
yeah, that's
we
true.
discovered
the
it
Lucy
later.
fossil, yes.
It was there for a very long time.
An early hominid, right, version of humanity found in Olduvai Gorge in Eastern Africa. Yeah, good stuff. And looks like the spacecraft Lucy is doing well and well on its way. And
yeah,
we're very excited for that. But it's always so neat to be able to see that sort of stuff. Sadie, did you have like the excitement of space exploration back when you were younger, like so many of us did?
Maybe not in such a big way for me. I think for me, it was just the excitement of starting to be able to see things in the sky with my own eyes, figure out that I could see satellites, that I could see the ISS when it was pointed out.
Yeah, I love that.
Things like that. There weren't any particularly huge events that I recall as being part of my childhood, though.
Okay. But you were able, I suppose, grew up in an area that was dark enough that you could actually see these things without the light pollution of, say, where we are right now in the greater New York City.
I mean, we can still see the ISS. It's pretty bright, but
yeah, you could see a bit. And we had a telescope at my high school that we would sometimes bring out onto the field in front of the school. I used to be a rower in school, and so I'd get up at egregiously early hours of the morning. Got to campus at that time, and practice was canceled. Our astronomy teacher would bring out the telescope for us before the lights had even come on yet. So
amazing.
early rising tendencies got me my first experiences with a telescope, actually.
That's amazing.
That's awesome.
That might be the first time, Sadie, that I've heard of somebody become interested in astronomy because they got up early in the morning.
As opposed to staying up
As
late at
opposed
night.
to me, who chose this career because I stay up really late at night. But that's really cool. And you're a rower, so I definitely want to talk more about that later because we've talked a lot about athletes being astronomers on this podcast a few times, and so I would love to hear about that because I don't think any of our athletes have talked anything about rowing and boats and crew and stuff. So that's really cool. I think that's great. So, what did you like about looking at the sky? I mean, what was it that led you sort of to say, I want to do this, or I want to let other people do this? That is there something there with there?
Yeah, that's a good question. I feel like I think about this a lot, and I don't have a great answer of what I loved so much about the sky, but my only memory is that studying astronomy and looking at the sky when I was really young was the place that I had the most questions, and I had the most
nice.
things that I didn't know or conceive about it. That I always loved learning about physics and how the universe worked, but something about standing around a telescope or just looking at a night sky with people and all of the thoughts I had being questions, nothing being something that we knew, and maybe a lot of my questions weren't even answerable to the foremost scientists of the day. So the idea that it was an area that was okay to have a lot of unknowns, that was something that we could celebrate the things that are still a mystery to us as much as we can celebrate the things that are discoveries. And it was almost like the whys and the wondering and the awe of it all was as important, if not more important, than having answers, than the problems. And
I love that.
Much in that academic mindset of I gotta find the answer to everything. I need to solve every problem. I only ever had questions looking up at the sky.
I love that sort of scientific inquiry mindset, like that. Like it's about the questioning as much as it is about finding a specific answer. Because every time you find something, you now have a whole plethora of new questions.
Yeah,
it's a really great way of doing things.
Well, I think that's true.
The awe and the curiosity of it. I'm having so many tangential thoughts that I won't go off on yet, but I took in college, my favorite classes was about the idea of awe, of AWE, and we talked about different things that cause awe on the natural world or in human endeavor. And I feel like this is an intersection of so many forms of awe that I was so awed and then curious to find out more about how we do the work that we do and that we put together the instruments we do and learn about these faraway things. And there's the awe of just the unfathomable. You can't wrap your head around what's going on in space the same way you can put an experiment in chemistry or biology on a table in front of you.
About that. I love that. And it's great that we are talking about this now. I sometimes feel like we do lose that when we're so focused on results, so wanting to know answers to this or that the why we're doing it is really important. So I think that's super cool. Tell us about the work that you're specifically doing about galaxies. You say you study galaxy evolution. So as you know, I also study galaxy evolution. So you got to tell me all the stuff that I don't know.
Absolutely. So the work that I'm specifically doing is using a galaxy's light and spreading it into spectra. So I'm studying the spread out light from a galaxy, and specifically the project that I'm doing is using citizen science to try and dissect different features in that light.
Ooh.
So we're recruiting help to our project is called Redshift Wrangler. So
that's a fun name.
Property of redshift is super important here. We want to find things like redshift that describe the properties of the galaxy just from what we can tell from looking at how its light is spread out at different wavelengths and different brightnesses.
That's
so we've talked about Redshift before on the show, but what is your little elevator pitch for explaining that to people?
So my elevator pitch for Redshift is that there's so many different things we want to study with galaxies. There's so much that we can tell about different features in a galaxy from looking at its spectrum. There's so much that we can tell about different systems of galaxies now by comparing them, but we can't put together almost any of those pieces unless we know something about the distance to the galaxy that I've tried to describe this in a bunch of different ways, and I think my favorite is the way I describe it to kindergartners in my kindergarten class. That my simplest explanation is if you have two different bodies in the sky and one is really bright and one is really faint, how do you know which one's closer to you or which one's further away from you? If you're, demonstrating that with your hand, how can you actually tell the distance to something just by the light that you're seeing from it? And we've got to know that in order to figure out the three-dimensional map of the universe, the actual physical locations of things. So if we want to study for example, life cycle of a galaxy, how it's born and evolves and changes over time and how they interact too. So we really need to know what the redshift is and what the distance is to a galaxy to know where that galaxy is located on the timeline of all cosmic history. We want to be able to tell how far away these galaxies are, where they are in three-dimensional space in relation to each other.
Oh, so redshift is a measure of how fast an object is moving. So how does redshift of a galaxy relate to the distance of a galaxy?
That's a great question. So the redshift kind of is related to the Doppler shift, I think is a good jumping off point. For,
sort of like when ambulances are going like wee wee wee.
Exactly. That when something in sound is moving towards or away from you, it changes in the pitch that you hear it. It changes the frequency of the wavelengths of the sound waves. And the same thing happens in light. When a light wave is coming towards us through space, if the object emitting the light is moving towards or away from us like an ambulance, then instead of sound, the light waves are getting either crunched or stretched. And redshift is literally how much towards the red end, towards the longer wavelength, was that light shifted. So it's describing the stretching of light, and the reason why galaxies are moving away from us and towards us is coming down to the expansion of the universe. So
nice.
All right. Well, there's a lot of cosmic concepts built into that one little thing, right? This idea that redshift measures speed. And so this Redshift Wrangler thing, is this sort of like a space cowboy for redshifts and galaxies? Is that how you want to do it?
Yeah, that's a great question. So we actually have this our little
that's cool
logo.
Oh, for those of you who are only on audio and don't see the YouTube, go onto the YouTube and see these. This is super cute. There's one like a spacesuited individual have a lasso with a multicolored rainbow kind of galaxy showing redshift and a cowboy hat, like Indiana Jones. Wow, too cool. I think that's lovely. And then the other one was like more rectangular, right? Again, like I said, these are very cute. So make sure to do these and take a screenshot and put them on your computers or something like that. Redshift Wrangler, very, very cool. I love that. And your point is to try to make it so that people, because it's a citizen science project, right? It can really do stuff.
Yeah. So we had a student, an undergraduate, a few years ago, make this design for us, and I really love the character, how it's taken on a life of its own now. That I think the best part of our Redshift Wrangler is that there's kind of a mysterious aspect to who's behind the hood of the astronaut. Anyone can be in there wearing the astronaut suit and doing the wrangling. It's kind of demonstrating the nature of our citizen science project, that you can put yourself in the shoes of this character.
Wow, that's terrific. I love that. How many people have used Redshift Wrangler to do this citizen science?
See, right now we're around 3,500 users have been on the Redshift Wrangler project. So
fantastic.
Great. Call our users Redshift Wranglers. How we're wrangling galaxies in the universe together. So we're nearing 4,000 Redshift Wranglers by now.
Fantastic. Wow. Considering that the number of actual professional astronomers in the world today is somewhat less than 10,000, you are basically marshaling half a workforce equivalent to half of all the professional astronomers in the world to do this project for you. That's amazing.
That's so true.
And you don't have to be a professional astronomer to do this, though. That's like the whole thing.
Yeah, right.
Exactly. Yeah, I think that this is kind of the thing that I think would have really mattered a lot to me and drawn me into science at the beginning was feeling welcome and invited into a space where real scientific research was happening. So our project is the kind of project where you aren't required to have any additional equipment, background knowledge, expertise. You need to have maybe an internet-enabled device, but other than that, you can come with a curiosity to learn, and then we walk you through anything you need to know about galaxies and spectroscopy. So anyone who feels capable of that can come in and immediately be looking at our real images, our real spectroscopic data of these galaxies, and jump into my PhD research.
Wow. That's like soon-to-be Dr. Sadie Coffin and a cast of thousands, right?
Exactly.
I love that. That's marvelous. We're going to get to some questions for the audience, right, Alan?
Yeah.
But you know what? Let's take a break right now real quick and come back for our questions. You are part of the LIUniverse today. Thank you, everybody. We'll be right back. Hello, everybody. We are back on the LIUniverse with Sadie Coffin talking about galaxy evolution and Redshift Wrangler. And we have a question.
Yeah.
Right, Alan?
We've got a question. So our first question that we're going to ask today comes from Nina, who is asking, a little bit technical here, if nothing can go faster than the speed of light, why can galaxies have z greater than 1?
Oh, right. So we haven't yet mentioned, right, Sadie, what z is compared to Redshift and why this 1 is a speed limit or whatever.
Exactly. Yeah. So I think I know exactly what Nina is asking, and that's a great question. So there is a set speed limit for anything in the universe. As far as we know, nothing can travel faster than the speed of light. We usually refer to the speed of light as the letter c. And the redshift concept we've just been talking about, which describes the distance that an object is away from us because of the expansion of space, this cosmological redshift, is often called the letter z that Nina has referred to here. So the question of if nothing can go faster than the speed of light, how can you have greater than z greater than 1? Super interesting question that is actually super related to what I'm doing with Redshift Wrangler.
Yeah, so the scale of z is set up so that 1 represents something that the distance between us and it is increasing at the speed of light, right?
Yeah, so a redshift of 1 is describing kind of the shift in the wavelengths, and it's describing how much the space between us and that galaxy has stretched. So yeah, the value of z isn't actually describing our movement through space or our speed, where it's not describing the speed of light. It's talking about the expansion of space itself.
Wow. I see. Okay, so this redshift z is not like an ambulance moving at the speed of light or past the speed of light, but it is actually the expansion of the universe itself, which has created the appearance of an object moving faster than the speed of light.
Exactly. Yes.
Wow.
The redshift is describing how much the space has stretched since the light left that galaxy. It's describing what we're seeing from a galaxy. It's not actually describing what that galaxy is moving all the way at the other end of the universe.
So if something is redshift 1, then it looks to us like it's moving at the speed of light away from us, but it means that it has stretched the universe like twice the distance or something like that, like a whole extra length of the universe.
Exactly.
That's out of control. That means that what we see when we're looking at an object at redshift 1, that means the universe was half its current size when the light left that object.
Yeah, we like to say on Redshift Wrangler that using the light from distant galaxies is the closest that we get to using a time machine, that we're looking back in time at how things were around the time of the beginning of the universe and way long ago in our cosmic timeline that we want to study.
Wow. Are there a lot of objects that are greater than z of 1?
Yeah, as far as I know, I don't know what the number is that we've found at this point. Well, I mean, think we're finding new galaxies every day at higher and higher redshifts. Kind of the limit of what we think is possible expands every day as our science gets better.
Wow. What's the highest redshift object that you know of, or that you've worked with, that you've helped to discover?
I think right now is the limit somewhere around 13, somewhere in the teens that we've gotten up to. But I think that the actual highest redshift that you would recognize might depend on the validity of the method and maybe who you're asking and things like that.
Wow.
Yeah.
I just looked that up really quickly because I was trying to find the article about how Z is defined, and they're saying that the highest that they've found so far is 14.3.
Jeez.
Wow.
Who is they? Who is they?
It is called JD's GS Z14-0, and it's JWST result.
Hey, good old JWST. You're working on that, right, Sadie? I mean, you're doing some. Are some of your Redshift Wrangler objects from JWST data?
So not yet. So far we've been working with a lot of galaxies and objects kind of from our archival spectroscopic catalogs. So we have, we have like 250,000 spectra in the region of the sky called the cosmos fields that we've referenced a couple times. So
we
have
love that.
a lot of existing data, and it's, this is a 2 square degree region that's a few times the size of the full moon. So in like a little region on the sky, we've identified almost 2 million galaxies, and then from that 250,000 spectra waiting to be analyzed.
That's awesome.
Amazing.
So
Amazing.
we would love to work up to space-based data, and hopefully we'll soon get to some Hubble Space Telescope spectra, and down the road probably JWST spectra. But yeah, so far we've started with this ginormous abundance of data that we have at our disposal, which was a little bit of the motivation for launching the project. What's a clever way of going through all of this data. We definitely can't do it as an individual or a few people, every day going through 1 out of 250,000.
Yeah, with 3,500 people makes it a little easier, I guess.
Wow. So these spectra, they're of objects of all redshifts, as far as you know. Are they all faint? Are they all bright? Did they have any kind of rhyme or reason in this Cosmos survey? I mean, those of you who have been listening and watching the LIUniverse know that we had one of the captains of the Cosmos project on our show in a previous season, Dr. Jehan Kartaltepe, and tell us a little bit about this cool stuff happening. What is actually happening with all of these spectra? I mean, what's going on?
Yeah, so I would say definitely check out this previous Jehan expert episode for a deeper view into Cosmos. And generally, our approach at starting off with Cosmos data and Cosmos spectra is kind of based on the idea that we're assuming the Cosmos field is a pretty good representative of the galaxies in the sky. We have to kind of make the assumption that most areas of the sky that we're going to look at have similar systems in them, that if we're looking at a large enough area that we're going to have a characteristic sample of galaxies. So we're starting off with all of this data at our disposal because of the desire to add to the catalogs that already exist. So we want to build up, there's something called the Cosmos Spectroscopic Archive, is this archive that we're building up, or there's a postdoc, Ali Ahmed Kostavan, who's building up the Cosmos Spectroscopic Archive. We're looking to just help use citizen science to contribute spectroscopic measurements that we can add to a big collection that scientists can then use, that any of these objects you might want to study, you can have a redshift at hand, in redshift in hand to look at more in depth at whatever you want to study.
Oh, that's great. So it sounds like Alan, make a note. Ali Ahmed Kostavan is a person we should have on in a little while, maybe next season, so that we can get even more about this cool Cosmos.
There's a lot of cool people involved in this project and all the projects.
Yeah, it's so much fun to talk to everybody. As longtime listeners understand, right? Part of this whole podcast thing is the joy of talking to young scientists or earlier career scientists that are doing like the cool, hot things that I only peripherally am able to do, given that only one person can only do a few projects at a time in their life.
Yeah.
So it's great, Sadie, that I thank you for letting us know that all this cool stuff is happening, and for letting people like be able to participate in it as well. I mean, this Redshift Wrangler sounds like fun. I know that there are citizen science projects popping up all over the place, but how did the Redshift Wrangler concept come about, and how should we, those of us who are listening or watching on YouTube or are otherwise, curious about being part of this? I mean, how do we go about it? Give us a little bit about all that.
Totally. So for Redshift Wrangler is hosted on a platform that, if anyone has done citizen science before, may be familiar with, called LIUniverse. So LIUniverse got its start and its name from the project Galaxy Zoo, which is a highly successful citizen science project and is also looking at galaxies. But LIUniverse is kind of a treasure trove of different projects looking at all kinds of science, from ecology to literature, to history, to wildlife. And I started first diving into LIUniverse in the pandemic when I wanted to get involved in some science and learn new things while I was working at home. And I started diving into different ways that I could, and I was learning about nesting habitats of penguins in the Arctic. And there were projects where you could transcribe the old field notebooks of like historic figures or of like iconic female scientists and things like that.
Amazing.
So I was really enjoying getting to know citizen science, and I'd had people point me in that direction a little bit as I was getting really interested in science communication and outreach and things like that.
Yeah.
And coming to RIT, they had just started to put together the Redshift Wrangler project and had just received the initial seed funding for the project. So when I first came to RIT, I joined the Redshift Wrangler project as we were assembling it, putting together the LIUniverse website that you can go and find now. And then about 2 years later, we launched it to the public. And now you can go and check out everything that we do on there.
Wow.
That's awesome.
Does that take a lot of time? I mean, is it really, really hard?
Yeah, so there's so much that I feel like I didn't know about leading a citizen science project coming into it that I've learned now in retrospect. And one of the biggest things was that I assumed, I think, building a citizen science project, and especially putting together Redshift Wrangler, that the hardest thing, the biggest challenge of citizen science of Redshift Wrangler was going to be convincing anyone to come look at what we were doing, was going to be finding how do I convince people to care, and no one's going to want to come and do the work I'm asking them to do. And that was not the case at all. People are so interested in what we're doing, and they're so excited to be part of science. And in fact, citizen science is not about me putting out a call for data machines. We're not looking for people to come in and, do my work for me or just chug away and measure data or analyze data for us. It's really more about a give and take, where we're looking to get the different perspectives of people who aren't experts, and we're looking to have various eyes on our data. We're looking to build a community and to engage with people in a way that builds up their expertise and confidence and skills, because in turn that is going to make both our projects stronger but our results better as well.
Yeah, that's great.
So yeah, the most challenging parts were just learning what was important and realizing in retrospect the lessons I wish I knew going into it, that there's so much to think about in the building of community and in considering what your audience needs and wants, rather than definitely important for me to consider how do I communicate complex ideas and topics in spectroscopy and Redshift. But I thought that was the only or the main challenge. I thought no one's gonna stick around or pay attention past what I have to say. It was so much beyond that. It was more about once people are here, who are you attracting, and how do you now make this a place that they can get what they need from it, and that they can contribute their own ideas and their own perspectives, and that they can make your science better in turn.
So these citizen scientists really are true scientists. They are definitely in that same mode of inquiry, as opposed to just repeating something, some sort of task And I think that's really cool to know. And this community thing is super cool.
For sure.
Wow, I love that. Alan, do we have a question from our audience that is relevant to this particular thread of conversation? I think this is super neat.
Yeah, so we have a question sort of relevant to data crunching machines. This question comes from Jerry, who asks, will we someday no longer need scientists and have AI do all our research?
Ooh. Ooh.
Ooh, interesting. I feel like I kind of hope that there's still stuff for us to do just because it's fun stuff.
I think this is related to a question I get a lot about citizen science too, that a common thing people wonder when I'm talking about citizen science or deciding to use citizen science on Redshift Wrangler is, why can't we do that with machine learning? Or that sounds like a great project for an automated method.
Mm-hmm.
And I'd say it kind of in response to both, that I think these things can be complementary and that it can't be one or the other, really, that in the name of improving science and finding better methods, we can't forego one for the other, that if we were to get rid of scientists altogether,
Yeah,
science might not really be science anymore. Like what we were just talking about, science isn't just about churning out data. It's, depends how you want to define an act of science. This actually brings me to that we just finished Citizen Science Month in April.
Oh.
SciStarter, the Citizen Science Institute, or the Citizen Science Program SciStarter, they organize a 1 million acts of science campaign every year in the month of April, where they partner with citizen science projects like Redshift Wrangler, and they try and encourage 1 million acts of science to take place throughout the month.
That's really cool.
I think we passed by a large margin this year, but I have
yet to see
final numbers. But it's kind of all based on the idea of what we want to call an act of science. So each project is reporting how many acts of science you saw in your project each week or throughout the entire month. And that can kind of be whatever you define it to be. So for some projects, like for a LIUniverse project like Redshift Wrangler, it's easy to think about when you click the buttons on LIUniverse project on Redshift Wrangler, you're submitting your classification. That's kind of an easy act of science. You've looked at an object and maybe you found nothing, but maybe you found features in the spectra.
Mm-hmm.
Another act of science that I define as an act of science is asking questions, that anyone who has asked a question on our talk boards or answered a question on our talk boards or engaged with another citizen scientist, that's also an act of science that's contributing to our tally. So nice. I think that the community and the creativity and the human connectedness and kind of judgment of it all is a really important part of science, and kind of the nature of us turning to citizen science is because humans, citizen scientists, and the human eye are really good at finding patterns and nuances in data in a way that automated methods can't really do that well yet, or at least on their own. So when I get that question at talks a lot, I always think of the best way to answer it, that I think automated methods, machine learning, citizen science can go hand in hand. That who's to say we're not putting together really great training sets for future machine learning algorithms as we're doing our citizen science.
Mm-hmm.
But as it stands, we can't do the work that humans are doing by looking at our objects and boxing features. The machine isn't really that good at that yet.
Very cool. So we're not obsolete yet, and we may never be if we ask the right questions or have the people ask the right questions.
Yeah, I feel like someday is a very long time. It's possible that 1,000 years from now, or 100 years from now, like we get AIs that are able to finally have some of those human aspects, like asking questions and being able to think critically and being able to wonder. Even maybe someday our technology will get that good, but that's a someday question. That's not a today question.
And we can think philosophically too about the past when we had citizen writers, citizen readers, before literacy was common amongst human populations, or before we knew how to write. They were just specialists who illuminated their
like
manuscripts,
scribes and so forth.
Or people who actually spoke stories. And today, like the majority of humans can read and write, And as a result, our society has been transformed, not destroyed, right? It's a positive overall as opposed to a negative. So I think that's really neat. Okay, so you're contributing to that, right, Sadie?
Definitely. And I think that this is something that in my brain connects with why science and art are so similar to each other. That this is
Yeah.
I've thought a lot in the past about in art history classes and in my love for spending time in museums, that I know in the art world there's a lot of debate about what really constitutes art. And you know, there's a lot of probably unanswerable questions about who can be an artist and who art is for and who art is of, all of that. I think there's a lot of similarities there in the way that science and art both kind of bring this sense of making meaning of something, of looking closely and noticing things. You know, everyone who looks at a work of art might notice something different and might see something different. And for me, that's so similar to what we're getting out of citizen science, that people might come in and see such different things in our data that are actually valuable to us. And the close looking and the noticing, finding patterns is as important as the answer that we're trying to get to as well. It's kind of the experience you have with the art or of the data is what's going to lead us to ask the next questions and form more community around the science. So I think of a lot of that as like a distinctly human trait of looking closely, of noticing different things. And I'm sure you can artificially manufacture differences, but there's, you know, a big value in the diversity of perspectives that you get from people looking at the same data
in different ways.
Different ways. Yeah, I thought a lot about experts. If I had 3,500 experts, that might not be preferable to the citizen scientists that join our project, because there's actually a lot of value in people coming in without bias and coming in to learn and then learning with us about what we're looking for and then finding what their eye points out, not for what they think should be there, which is what I might look for.
Interesting. Yeah.
You know, I am reminded of Albert Einstein when he published an essay in 1930 called What I Believe, where he believed that art and science both came from the same source within people. I think that's really terrific. And you have just put your finger right on that. I think that's awesome, Sadie. Speaking of art, I want you to tell me about those cool posters in frames behind you. Those of you who are not on YouTube, please jump onto the video part so you can see all this cool stuff back there. What is that? That looks really neat, actually.
Yeah, these are all posters that I picked up at a previous AAS conference.
American Astronomical Society.
Society. And the center one here is of the JWST, the Webb Space Telescope. And this ones on the sides are other NASA. I think it might be made by Chandra, the the Chandra X-ray Observatory.
Okay.
And they remind me a lot of travel posters that I've seen before. So when I was working with the NRAO a few years ago, I had the opportunity to
the National Radio Astronomy Observatory, NRAO, right?
I had the opportunity to interview the artist Tyler Nordgren. He makes the travel posters that I have around here somewhere, but he makes these
like the exoplanet ones,
yeah. There's ones that look like the style of what you'd see if you went to a national park and you were being advertised a family vacation. But he's made posters for the NRAO of all of their different instruments. So they have the NGVLA and the ALMA telescope array and the VLA and the VLBI. They all have these remarkable travel posters.
That's great.
And I love the way that he creates that art to kind of make space more familiar. I thought these reminded me of that because they've kind of put people into this space landscape in a way that's very imaginative and that can make you feel a lot closer to things that are so unintuitive and unfathomably large or far away or wrap our minds around. So I really love the way that Tyler makes art with space and the way that NASA makes these fun travel posters to
show
you how fun and accessible and engaging space can really be.
Wow. So Tyler Norgren is one of those examples of the classic person who does both art and science, and it comes from that same source and creates connections with all of us in this way. That is super neat. I love that. What are you going to do with all the data that you get from your Redshift Wranglers? What is your plan?
So we might say that there are multiple goals in Redshift Wrangler. Actually, this is one of the things that I think I've learned over the course of leading a citizen science project, that I really went in thinking there was one goal, and that goal may or may not have been me completing a PhD. But there's kind of the overarching Redshift Wrangler project goal, the goal of, the multiple goals of creating a successful project that produces redshifts, putting together a redshift catalog, and then there's the then there's the additional goals of building community around astronomical spectroscopy. There's the goals of whatever our volunteers' goals are, of meeting their learning needs and of answering questions and asking questions about space. And then kind of further down the road, there are goals with what we might do once we have extracted data from Redshift Wrangler. So I think I mentioned briefly earlier that there's kind of an initial next step where we want to put together a catalog and have a bunch of Redshift Wrangler redshifts accessible to the public, to anyone who wants to do a project that involves Redshift. But personally, that will be something I will use in my PhD as well. So I'll definitely be using redshifts to do additional analyses, and I will be focusing on galaxy pairs, seeing how we can find interacting systems in our data in ways that we couldn't before we had the spectroscopic information.
Wow. I love that. I think that's marvelous. And, we are really running out of time. I'm just so happy that you're talking about this sort of human connection to the science, this community building, which is so important, and getting people to do science who otherwise might feel like they're not, able to do it. But we have to talk about your rowing, okay? Because before we end this episode, you got to tell me that, because I just want to learn more. How does that connect? Or does it have to? I mean, it doesn't have to connect at all, right? If it's just something you do in addition to the science that you do and the art that you do and things like that.
Absolutely. Yeah. I think rowing informs a lot of the qualities that helped me become a scientist, and that I still carry with me to today. And a friend of mine told me years ago in college that rowers are really heroic, that in Greek and Roman epics, rowers are the heroes. Rowing often can...
Oh, yeah, like Jason and the Argonauts.
Yeah, when you're rowing away from the Sirens or Scylla and Charybdis. So beyond saving my life, maybe, I think there's so much about rowing that has shown me things like how you keep going when something goes wrong. And like what I've already talked about, where everyone might come into a citizen science project or a boat on the water with different goals and expectations for what they want to get out of it, what their personal ambitions are. But you have to kind of become a community and recognize each other's goals and each other's intentions in order for it to be a cohesive group. You need to set out your goals, and you need to honor what everyone else's motivations are. So there's so many things that I feel like I've carried into science about, continuing through hardship or consistency or rhythm, even repetition. Rowing is doing the same thing over and over again, which I can sometimes recognize in science, this, the mental battle that really, I think rowing for me, so much more than as a physical sport, was a mental battle of figuring out how to do something that is really physically challenging, but that that you see value in. And so I've taken so much from rowing, I think, about being a leader, having confidence, being a scientist, being able to correct my wrongs and keep going.
Wow. We have so much more to talk about, but we are out of time. We should stop this time, but we will talk more. Okay, Sadie, when you get up to 35,000 or 350,000 Redshift Wranglers, you come back and you tell us all the cool stuff that you're going to be doing, okay? In the meantime, where can we find this Redshift Wrangler or anything that you're doing? Keep up with the work that you're doing and the cool things that you're being involved with.
All right, you can find Redshift Wrangler on the LIUniverse website. If you Google Redshift Wrangler, the website should pop right up, and you'll be able to find other ways to contact us on that website, or you can search for Redshift Wrangler on Facebook or Twitter. And you can also find me on Twitter, but I'm contactable at any of the Redshift Wrangler platforms as well. So you can reach me through any of those methods.
Great. I hope all of you out there do precisely that. Sadie Coffin, I want to thank you so much for making this awesome episode with us and telling us about this cool stuff that you're doing and literally the cool stuff that we all can do thanks to you in astronomy. Thanks, Sadie.
Thank you.
As always, our co-host, Allen Liu, thank you so much for doing this. I really, really appreciate it. It's a real pleasure.
Yeah, of course. Glad to be here.
And for all of you out there, thank you for being with us today. If you like what you've seen and heard, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.